Hello, in this video I consider three problems from elementary probability theory offered on AMC-10. So the first problem is taken from AMC-10A 2006, problem number 13. So a player pays $5 to play a game. A die is rolled. If the number on the die is odd, the game is lost. If the number on the die is even, the die is rolled again. So I feel this is a tree diagram. So I have to start from the beginning. There are two options. So if the number on the die is odd, so then game is lost. Game is lost. So the probability to have an odd number on a die is a half. So if the result is even with the probability of a half again, then you continue the game and the die is rolled again. In this case, the player wins if the second number matches the first and loses otherwise. So we have to put it on the tree diagram somehow. So match. So if the next number on the next row matches the first, it means there is only one possibility, one number that matches the number from the previous row. So the probability then is 1 out of 6. It's only one favorable number. I don't know this number. It will be known after the first die is rolled. And there are 6 options overall, so the probability is 1 over 6. So we lose the game again with the probability of 5 over 6 because the two probabilities summed up must give us exactly 1. So if the two numbers match, then we win. So how much should the player win? So I don't know my prize, I don't know my award. If the game is fair, so in fair game, the probability of winning, I can find the probability of winning just by following this route on my tree diagram. It's a half first. This is the first event that must occur. The first number must be even, and after that, the probability is 1 over 6 because the second number must match the first number. This is the probability to win the game. So the probability of winning times the amount won. So it's X, I don't know. It's what I'm looking for. Is equal to, is what the player should pay. It's $5. It's $5. So I solved this equation just by multiplying both sides by 12. So it gives me 60. $60 is my expected win if it's assumed that the game is fair. So this problem teaches us to fill in the tree diagram correctly. So it isn't an easy task as you could think about it. Okay, let's move to the next question. So next problem is from AMC-10B 2006, problem 17. Bob and Alice each have a bag that contains one ball of each of the colors blue, green, orange, red, and violet. 1, 2, 3, 4, 5. Okay, 5. Bob. So let's draw a box with blue, green, orange, red, and violet. So there are 5 colors. Alice. Also the same set of balls, blue, green, orange, red, and violet. Alice randomly selects one ball from her bag and puts it into Bob's bag. Okay, she puts one of the balls selected randomly. Okay, Bob then randomly selects one ball from his bag and puts it into Alice's bag. Okay, there is an exchange of balls. Bob, okay, what is the probability that after this process the contents of the two bags are the same? Okay, so the contents of the two bags are the same. So this event can be like split on two events. First, Alice chooses any ball from her bag. It doesn't matter what ball is chosen, what color of the ball is chosen. So the probability to choose any ball is 1. Okay, you take any ball, let's say without loss of generality, we could think of the first ball taken from Alice's bag, green. It was green ball. So we put it in the Bob's bag. What must happen after that? Bob must choose green ball in order to return it back to the Alice bag. Then the contents of the two bags are the same. So we have to understand the probability of choosing this double color from the Bob's bag. So there are two favorable outcomes, and there are 1, 2, 3, 4, 5, 6 outcomes in total. So they are all equally likely. So the probability is 1/3. Where is it? D. I think you should take your time and understand that this is the only possibility to have contents of the two bags to be absolutely the same. You choose any ball from Alice's bag, you put it in the Bob's, and then you choose the same color as you just put in the Bob's bag and return it back to the Alice bag. So this is the only possibility. So that's it, it's D. So if you know the structure, if you know the idea, of course, the solution is pretty fast. So the next problem, it's AMC-10B 2008, problem 16. So 2 fair coins are to be tossed once. Okay. For each head that results, 1 fair die is to be rolled. Okay. What is the probability that the sum of the die rolls is odd? Note that if no die is rolled, the sum is 0. Okay. Okay, I feel it's a tree diagram again. So there are 4 possibilities when 2 fair coins are tossed. They are head, tail, tail, head, and tail, tail. So in case of 2 heads, we have to roll 1 fair die for each head. So you can imagine this massive table with 1, 2, 3, 4, 5, 6 on the as the result of the first die, 1, 2, 3, 4, 5, 6 as the result of the second die, and you can imagine the probability that the sum of the die rolls is odd. Exactly half of the entries in this table, they are filled with odd results. So the probability to have the odd result is a half. So, but oh, I forgot to fill the these branches. So what's the probability to have head and head? It's 1/4. 1/4 for head and tail, 1/4 for tail and head, and 1/4 for tail. So after that, the probability of having odd result is a half. If you had head and tail on the 2 fair coins, then it's only 1 head and you have to roll the die only once. If you roll the die only once, the probability of getting an odd number is 1/2 again. So I think it's better to write it a bit differently. So a half the probability that leads to odd result, a half the probability, a half of getting an odd result. Again, a half, it's a probability to get an odd result because it was just one head. It means one die must be rolled. In case of two tails, no rolls. And as they said, the sum is zero, but zero is an even number. So the probability of getting the odd result is zero. Okay. So then we consider all cases. So in order to get to this odd result, one force must be multiplied by 1/2. So you just move along the branch of the tree. Or you say, or it becomes a plus sign, or we consider the second possibility. Its probability is 1/4 times 1/2 again, plus the third possibility, here it is, 1/4 times 1/2, plus the last possibility has zero chance, 1/4 times 0. So it's 3/8. It's 3/8. It's choice A. That's it. So you can see that the tree diagrams, it's very popular methods of solving problems and probability theory. But to be honest, it's only about the elementary cases, elementary problems and probability theory. So I hope you found something interesting for you. So see you next time in the next video.